Hello students, how are you? Are you all fine? Myself is Amir Raja. Today I will teach you the very important topic, system of linear equation of the chapter determinant. And this is a system. Why it is system? Because there are more than one equations. These are the three linear equations having unknown x, y, z. You can say variable. Means number of equation is same as number of variable. So I have to solve this system of equation, means I have to find value of x, y, z which will satisfy all three equations simultaneously. So to solve this system, we will see the determinant method, means we are going to see the Cramer's rule. Here 4 determinants are used. Delta, this is made by the coefficient of coefficients. Here coefficients are A1, B1, C1. A1, B1, C1 first row, and second row from the second equation A2, B2, C2, and from third equations A3, B3, C3. This is the delta coefficient determinant, I can say. And now delta 1. You can see here these numbers are the A1, A2, A3 are the coefficient of x in three equations. Okay? And second column B1, B2, B3 are the coefficient of y, and third column coefficient of z. So in delta 1 I will replace these numbers by the constant values in the first column D1, D2, D3. In the place of coefficient of x I am writing D1, D2, D3, and remaining column remains same. And delta 2, how can I write delta 2? You can guess. We will replace in delta, we will replace the coefficient of y by the D1, D2, D3. So second column में लिखना है, I have to write D1, D2, D3 and remaining two columns as it is. A1, A2, A3, C1, C2, C3. And delta 3, you can guess, in the place of third column, I have to write D1, D2, D3. And remaining two columns remains same. Okay. Now Cramer's was the mathematician who derived the solution. Cramer's rule. He said that the delta 1 is equal to x into delta. Similarly, delta 1. Okay. And so delta 2 is how much? You can guess, y into delta. And delta 3 is how much? Z into delta. Okay. You can see here in delta 1 I have replaced the coefficient of x column by the D1, D2, D3. So delta 1 is x delta. Here coefficient of y is replaced in delta 2 here by D1, D2, D3. So we are getting delta 2 is equal to y delta, and similarly delta 3 z delta. So this is the Cramer's rule, and this is the correct form of Cramer's rule. In books you will find x is equal to delta 1 by delta, y is equal to delta 2 by delta, and z is equal to delta 3 by delta. If we will write it like this, then many things which are going to cover in the next, you will face the problems. So this is the correct form. Now first I will prove this and then I will proceed further. Okay? You can write. You must have pen and paper with you, and you can pause the video and write all the contents. Okay? Now I will prove first. So proof, I have to prove delta 1 is x delta. Okay? So this is my delta 1. See here. So what is D1? D1 is this much. So in the place of D1, I will write this A1x plus B1y plus C1z. In the place of D2, we'll write this expression a2x plus b2y plus c2z. Similarly, D3 is this much. Then now B1, B2, B3, C1, C2, C3. Okay. Can you guess what the operation I am going to? I have to prove it x delta. Which operation? See here, B1y, here is B1, B2y, here is B2, B3y, here is B2, here is B3. Similarly, C1, as here is C1z, C2, C2z. And I will apply this operation. C1 goes to C1 minus this into y into C2 minus z into C3. Then these terms will be eliminated from here, and we'll get delta 1 is equal to, this is the delta 1, is equal to a1x, a2x, a3x, b1, b2, b3, c1, c2, c3. And this is how much? Here in the first column you can see x is a common factor, so I can take x outside. Is the property of determinant. A1, A2, A3, B1, B2, B3, C1, C2, C3. Okay? And this is our x into delta. This is the delta, x into delta. Here delta, you can see x delta. Hence, we have proved Cramer. So delta 1 is equal to x delta. Similarly, if we write d1, d2, d3 in delta 2, we will prove delta 2 is equal to y delta. Similarly. Next. Now I will come to the solution part. So before reaching to that, there are three cases for this system. Sometimes we get a unique solution, means one set of three numbers, that I can say triplet. One triplet which will satisfy all these equation, that means one solution. And sometimes we get infinite number of triplets possible which will satisfy all this equation, hence infinite solution. And sometimes we don't get any ordered pair, any triplet, then that means we get no solution. So what are the conditions I am going to see here? And similarly, you know, you have studied in the 10th class, in which we would solve system of two linear equations in xy, and then there also we had three cases. Okay? Similarly here. Now I am going to find the condition. Okay? I am going to take it. Next, first case. We have proved delta 1 is equal to x delta, and delta 2 is equal to y delta, and del 3 is equal to z delta. We have proved that. Okay? Suppose delta is non-zero. This is the condition. If delta is non-zero, that means we can divide by this equation by delta. So delta is non-zero, then we can divide. X is equal to delta 1 by delta. Similarly here, y is equal to delta 2 by delta, and z is equal to delta 3 by delta. Okay? Since delta 1, delta 2 all are the determinants, means numbers. So it is a unique number, unique value of x, unique value of y, unique value of z. So there is the one triplet, that means unique solution. That means for unique solution, what is the condition? This is the condition for unique solution. I have to remember it. This is only one condition, delta was not equal to 0. If delta becomes 0, then what the cases will arise. There will be two cases. If all determinants delta 1, delta 2, delta 3 all are 0, that means infinite solution. Okay. But just for understanding, it is not true 100%. Just for understanding, see here delta is 0. First of all, delta is 0, and we write 0 is equal to x into 0. Then 0 is equal to, similar second equation, 0 is equal to z into 0. Then see what is the value of x which will satisfy this equation. Any value, 1, 2, 3, 4, any value. Just second, similarly for y and similarly for z. Hence there are infinite triplets. But remember, this is the not right, because every triplet won't satisfy all these equations. Just for understanding. Okay? I can remember. Means what are the condition? Delta 0 and all other 0 for infinite solution. Now if at least one of delta 1, comma delta 2, comma delta 3 is non-zero. See, first of all, delta has become 0. Then, and at least one of this is non-zero, then we'll get no solution. No triplet will satisfy the system of 3 equations. See here, just for understanding. See, suppose delta 1 is 1 and delta is 0 and delta 2 is 0 suppose. Delta 3 is also, I assume 0. Here you can see yz can be any number but x cannot be any number. That means our triplet is not completed. Hence, there is no triplet will satisfy all this equation. Hence, no solution. Okay. See, I am going to say one very important point. Just pay attention. It is very important point. This condition delta is 0 and this all are 0 is the necessary but not sufficient condition for infinite solution. I am repeating. It is necessary but not sufficient, because if one of them is non-zero and delta 0 and one of them is non-zero, that means we won't have infinite solution, 100% no solution. Okay? 100% no solution. But it is not sufficient, means if all are 0, all delta are 0, there is a possible that we don't have any solution. Okay? Won't have infinite solution. Okay? But if one of them is non-zero and delta 0, one of 3 is non-zero, that 100% no solution. Isliye for getting infinite solution, we must have delta 0 and all are 0. But if all are 0, then there is a possibility that we don't have infinite solution. Okay? I am taking one example. Take the example, x plus y plus z is equal to 3, x plus y plus z is equal to 4 and x plus y plus z is equal to 5. Okay? Suppose this is a system of equation. I am calculating here delta. Delta is how much? 1, 1, 1 and 1, 1, 1, 1, 1, 1. All 3 columns are identical, so its value will be 0. If suppose I am calculating delta 1, I will replace this by 3, 4, 5. Again 2 column will be same, identical, that means 0. Similarly delta 2, delta 3 all are 0. That means we should get infinite solution, but this system has no solution, because for every three numbers, if it satisfies this equation, then it cannot satisfy this equation simultaneously. So system has no solution, but all the conditions are satisfied. All delta has become 0, delta 2, delta 3, all are 0, but we don't have infinite solution. Okay? And second example, if I have x plus y plus z is equal to 3, x plus y, 2x plus 2y plus 2z is equal to 6, and 3x plus 3y plus 3z is equal to 9. If I am calculating delta here, it will be again 0, same as delta 1, same as delta 2, same as delta 3. But now this system has infinite solution. Okay? If you divide 2 by 2, then same equation. If you divide this equation by 3, same first equation we will get. That means this system has infinite solution. Okay? Here all are 0, that we are having infinite solution. Okay? I can point out where it fails. That was I am saying, that it can have infinite solution, it may not have infinite solution. Okay, may or may not. This is the case where it fails. However, when it fails, you can see when I am writing again a system of equation. This is the case when this condition fails, otherwise this condition is always true. Okay. Here, if any two pair, if I take any two pair, this pair or this pair, one pair, another second pair is this or this pair. You can take any two pair. If the ratio A1 by A2, B1 by B2, C1 by C2 are same as here, A2 by A3, second pair also, this ratio becomes same. That means this case can arise, or this case may arise also. If all are same and this is also equal to D1 by D2, if D1 by E2, B1 by B2, C1 by C2 is equal to D1 by D2, and this pair also, say A2 by A3, B2 by B3, C2 by C3 is equal to D2 by D3. If all three ratios are equal to fourth ratio also, that means इनका ratio is equal to इनका ratio. इसमें भी ऐसा हो रहा है, same thing. ठीक है, coming here, then we will have infinite solution. But if in any one pair, if these three ratio and these three ratio are equal, but in any one pair these three ratio is not equal to इनका ratio D1 by D2, then this will be the condition. Here you can say 1, 1, 1 is not equal to 3 by 4. It is wrong. That means in any one pair, if I am getting this three ratio equal but not equal to this ratio, that means we will have no solution. Okay? Understood? Otherwise, if the ratio is not coming equal, all three ratio are not coming equal, and all deltas has become 0, that means 100% infinite solution. Okay? If this three ratio is also equal to the fourth ratio in both the pair, then again we would have infinite solution. Okay? Understood? Okay. Now I will take one or two questions here. Suppose first question is solve following system of equation: x plus y plus z, x plus, चलो is equal to 2x plus 2y plus 2z x plus is equal to 8. 4, yeah, I am taking this. And second equation, x plus 3y plus 9z is equal to 14, and x plus 4y plus 16z is equal to 22. Suppose I have to solve this system of equation. Then solve. You can try also. What I'll do here, I will find all the deltas. Delta is how much? 1, 2, 4, 1, 3, 9, 1, 4, 16. You can calculate here. Just do the calculation, just expand, or you can make 0 also. Okay, 1 into 3 into 6, 48 minus 36 minus 2 into, first I am expanding from the first row, 2 into how much? 16 minus 9 plus 4 into 4 minus 3. You can calculate this, we will get 2 here. Now I am calculating delta 1. Okay. What is how I can write delta 1? I have to replace here 1, 1, 1 by 8, 14, 22, and other two columns remain same. Okay. Just expand and we will find this is equal to how much? 4. You can expand it. Delta 2. I have to replace this column by 8, 14, 22. Here is 1, 1, 1, 4, 9, 16. I will make 0 here. R1 goes to R1 minus R2, and R2 goes to, it will become simple, R2 minus R3. 0, minus 6, and minus 5. Here 0, minus 8, minus 7, 122, 16. I can expand from the first column, and 1 into 42 minus 40. That means 2. Similarly, just do the calculation. Delta 3, I will replace 8, 12, 14, 22 in the third column. I will write this in the third column, and remaining first two column of delta remain same. Same, you can make 0 here, and it will be again 2. Then, since here delta is non-zero 2, that means we will have a unique solution, and that solution is given by delta 1 by delta. Delta means how much? 4 by 2, any 2, and y is equal to delta 2 by delta. Delta 2 is how much? 2 by 2, that means 1, and z is equal to delta 3 by delta, and it will be 2 by 2, that means 1. So, system has unique solution, single triple will satisfy all these three equations. 2, 1, 1. This is x, this is y, this is z. Thank you.